Hi everyone. In this lecture, I'm going to show you how to name organic compounds. I've arranged organic compounds in the order from the lowest priority alkanes to the highest priority carboxylic acid. And normally nomenclature of organic compounds follows a priority. So let's say if I had a chain that has an alcohol and a carboxylic acid, then your ending is going to be in the carboxylic acid because the acid is a higher priority and the alcohol is going to be a substituent, so we're going to name it as a hydroxy. To name alkanes and alkynes, let's start with alkenes first. You choose the longest carbon chain that contains or that has the double bond. So if you have two chains, one has the double bond, the other one doesn't include the double bond, please choose the one that includes the double bond, no matter how many carbons there are in this chain. Even if it's a shorter chain, you have to include it. You have to choose it so that you can name your alkane. So always choose the chain, the longest chain that includes the double bond. If the chain is shorter, if the one that has the double bond is a shorter chain, choose it. You have to choose the double bond, you cannot ignore it. And when you choose the chain, make sure that you choose both carbons of the double bond. So you cannot go by 1, 2, 3, 4, and then 5. You cannot cross the double bond. You need to go by 4, 5, 6, 7, 8, 9, and 10. So now here my longest chain is a 10 carbon chain. So the first thing, choose the longest chain that has the double bond or the triple bond in case of alkyne. We're going to use the parent name in there. So for alkenes, we're going to drop the A and E and put E and E at the end. For alkynes, we're going to put Y and E at the end. We're going to use the same rules of naming of alkanes. We're going to give the double bond and the triple bond always the lowest number when we're naming them. And we're going to use the prefixes di, tri, tetra if we have more than one double bond or more than one triple bond. So in this case, whenever I want to name this, it's a dekene. The double bond is on carbon number 4, so it's going to be 4 dekene. So this 4 indicates that the double bond is on carbon number 4, and this is the ending for the double bond. And then you name the substituents in there. So on 4, you just open a brackets, you have one methyl and it's a propyl, and then on carbon number 2 you have a methyl group there. Now, whenever you want to name the triple bond, follows the same rules. So choose the longest chain that includes the triple bond and give your triple bond the lowest number. So give the triple bond the lowest number, choose the longest chain that includes the triple bond. Ending in Y and E, make sure that you have a number for the triple bond. Now, if it is on carbon number 1, you can skip that. So I could say 3-methylbutane instead of 3-methyl-1-butane. But if it is not on carbon number 1, I have to mention which carbon is it on. So here it's a 3-heptine. It tells me that the triple bond is on carbon number 3, and then you put your substituents in there. Now let's say, for example, if I had more than one triple bond. More than one triple bond, then I need to use the prefixes di, tri, tetra, etc. So here, 2 triple bonds, I need to start numbering from this end, giving the first triple bond the lowest number, and it's going to be a di and it's going to be an ine. Now, since I have a triple bond in there, 2 of them, I would need to name both. So it's going to be on carbon number 1 and carbon number 3 is going to be 1,3-hexa, and because it's a 6 carbon chain, and it's going to be a diene. Since I don't have a substituent, it's telling me here that the 1 and 3 are for the triple bond. Now, if you have if the chain normally if you have a double bond and a triple bond, both are in the same chain, always your ending has to be in the triple bond, always. So if you have a triple bond and a double bond, your ending is always in the triple bond. However, in order to start numbering, you have to give your first site of unsaturation the lowest number. So here, my triple bond is my first site. My double bond, no, because this is a carbon double bond, carbon CH3 and another CH3. So my double bond is on carbon number 2 if I start numbering from this side. Here my triple bond is on carbon number 1. So always give your first site of unsaturation the lowest number. No matter which site is it, an alkene or a triple bond, doesn't matter. So again, ending is always in the triple bond, always in the triple bond. Whether the triple bond is at the end or not, ending is in the triple bond always. And your first site of unsaturation gets always the lowest number. So here it happened that it's a triple bond. So I'm having 1, 2, 3, 4, and 5. So on carbon number 4, I have my double bond. So here's how I name it. It's a hexane. It's not a hexane anymore. It's an En. En indicates that I have a double bond. So I have to make sure to put where the double bond is. It's on carbon number 4. It's a 4-hexane. Now on carbon number 1, I have the ine, so I will put one ine in there. I could have put 4-hexane ine, but since I have more than 1 degree of unsaturation, it's good to put the 1 in there just to make sure that the triple bond is on carbon number 1, and then you put your substituent in there. Again, not always the triple bond is going to be on carbon number 1 if you have a combination of a triple or and double. But just make sure that your ending is always an ine. It doesn't have to be the lowest number. And then the lowest number goes to the first degree of unsaturation. If you have a triple bond and a double bond on both ends, so let's say for example, if you have a double bond and a triple bond at the same distance on both ends of the chain, then always give the lowest number to the alkene, and the ending is always an ine, which is in the triple bond. So the lowest number always an alkene if the triple bond and the double bond, they are on the same side. They are on both ends. So if I had a triple bond here, if I had a double bond in there, I would start by numbering, giving the double bond the lowest number, and then my ending is going to be an ine. If you have more than one double bond, then use the prefixes di, tri, tetra, and then in front of the ene. If you have a more than one triple bond, then you're going to use the di-ine in that case. With alkyl halides, you can name them as common and IUPAC. So with common name, just name the alkyl group first, and then follow that by IDE, methyl chloride, ethyl fluoride, and so forth. For the IUPAC name, just name the alkane chain and name the bramine or the halogen as a substituent, as a halo substituent, and try to give the first substituent the lowest number. When you name alcohols, there are two ways to name alcohols: common and IUPAC. And as we mentioned before, common names, they are used for smaller alcohols or smaller organic compounds. Then you can name them as a whole. Like for example, in this one, this is called tertiary butyl alcohol. This is isobutyl alcohol. This is isopropyl alcohol. So these are all common names in there. Instead of saying basically instead of saying 1,1-dimethyl ethanol, then I would say it's a tertiary butyl alcohol. Now, for the nomenclature of alcohols, normally alcohols, they are named as hydroxy if they are prefixes, meaning if they are a substituent. But if they belong to the main chain, then the ending has to be in OL. So all what you need to do is drop the E of the alkane and end in OL. Like for example, in here, I know that this is propane. If it was an alkane, so I drop the E and put an OL, it's going to be propanol. Now I have to indicate where the OH is if it is on any other carbon other than 1. But if it's on carbon number 1, it's fine. I can drop the 1 and say propanol. But if it's on carbon number 2, I have to specify where my OH is. So see, the ending is going to tell me what type of functional group I have. This here is going to be butanol. I don't have to say what a butanol in there. Now, if you have a chiral center, just make sure to draw or write the configuration of that chiral center and indicate where the OH is. It's on carbon number 2, so it's going to be 2-butanol. 2-methyl-1-propanol in this case. This is an isobutyl alcohol. This is starting with this carbon. This is carbon 1, this is carbon 2, and this is carbon 3. This is 2-methyl-2-propanol in there, which is the IUPAC name of the common tertiary butyl alcohol. Now, if you show stereochemistry, or if you have stereochemistry, you need to specify it by cis and trans. If the groups are on the same side, then it's cis. If the two groups are on opposite sides, then it is going to be trans. Ending is going to be in OL. Now, if you have a bicyclic system like this one, this is a fused bicyclic system, always start your numbering from the joint side or from the joint carbon chain or carbon side, and then go along the carbon cycle or side that has the most carbons. Here in this case I have 4 carbons on this side, 4 carbons on the other side, but I can choose by giving my OH the lowest number in this case. So it's going to be it is a bicyclo, it is a 4-4, and it's a decane. See, now the OH is not a substituent, so I cannot name it as a hydroxy. It is part of the main chain. So my ending is going to be, instead of, this is 10-membered ring, it's going to be 10 decane, it's going to be decan, and then you drop the E and put an OL in there. Now here's the thing. If you keep the E and you have a vowel of O, this is wrong. So this is why I need to drop the E there. Now on carbon number 3, I have my alcohol. So I could have said bicyclo 440 3-decanol. I could have done this. I could have said that this is a 3-decan all. Okay, so I could have done this, or I can take that 3 and put it between the decan, the parent name, and the all. Okay, and either one of those is correct. If you have a double bond, if you have a double bond and an alcohol, now I know between double bond and an alcohol, alcohol is the higher priority. Just look at the table up there, all the way up. Alcohol is a higher priority than alkenes, so the ending is going to be in the OL. So that's going to make my alkene a basically a prefix, which is a substituent. So I have to write it down on which carbon it is. Now, it's not my priority to give the double bond the lowest number. My priority is to give the OH the lowest number because this is the parent name. So that is going to be 1, 2, and the 3, 1, 2, I'm sorry, and the 3 and 4. So your OH is on carbon number 2 rather than being on carbon number 3 if you start from this side numbering. So that is going to be 2 all, and I know that it's going to be at the end. And then carbon number 3, because this is where the double bond starts. On carbon number 3, you have a butane, so it can be 3-butane or but-3-N, whatever you go ahead and you choose, and both are right. Now, if you have an alcohol and NH2, NH2 is going to be a substituent in that case, and that substituent we call it amino. So it's going to be 2-amino cyclobutanol. 1 is optional in this case. If you have compound that has more than one OH, then this is going to be a diol, a triol, a tetraol, and so forth. And this is how you name them. You name the poly alcohol in there. You name the parent chain as an alkane, and you stick the word diol triol in there. No need for you to drop the e, because now I have the di in separation between the propane and the OL, so I could include the di in there without even dropping the e. Now, with respect to unsaturated alcohols, now these unsaturated alcohols in there, as in this example here, this unsaturated alcohol, as we mentioned before, the first thing you need to show the double bond by changing the infix from an AN to EN. And the infix is basically this over here. So you go ahead and you change it from a butan to butane. So you change it into an EN. You have to indicate where my double bond is, because it's a lot of functional groups and it's a double bond and an OH. My OH is a higher priority. It goes at the end. So it's going to be butane 2-all, or it can be but 3N. So now I know that in front of the double bond is on carbon number 3. The alcohol is on the second carbon. It's on the second carbon. Naming ethers. Now, in order to name ethers, ethers are named either by a common or an IUPAC name. You have symmetrical ethers and unsymmetrical ethers, and both, if you want to name them as common names, you just name both R chains or R sides of the ether, arrange them in alphabetical order, put them in the name, and stick the word ether at the end. So I know that this is secubutyl, I know that this is methyl, just arrange them in alphabetical order, and I know that the butyl comes before the M, so it's going to be secubutyl, methyl, and an ether. If you have a symmetrical ether, then you go ahead and you name the R chain, and you put the prefix di in there. Di, so it's going to be diethyl and then ether. This is a dimethyl and an ether. When you name ethers as IUPAC, then the easiest way is to convert the alkoxy name, to convert or to basically name the longest carbon chain. So you choose the longest carbon chain and you name the OR as an alkoxy. Okay, so you choose the longest carbon chain and you name your OR as an alkoxy group. So the smaller alkyl group, which is here the OR, this is called the smaller alkyl group. This is the longer, this is the smaller. You just name it as an alkoxy as a substituent. So this is the OR, smaller alkyl group, you name it as a substituent. Smaller alkyl group, you have two of them, you name them as a substituent. The substituent is named as an alkoxy, so it can be methoxy, ethoxy, tertiary butoxy, and so forth. So let's have an example over here. You name the smallest R chain as a alkoxy, so that's going to be methoxy. That is going to be an alcohol, so I know now that my parent name has to end in the OH. It should end in the OH. The OH is going to be carbon number 1. That is going to be carbon number 2. This is cyclohexanol. So it's a cyclohexanol. I dropped the E of the alkane and put an OL. Remember, no two vowels next to each other. Carbon number 2, it's an ethoxy. Both are chiral centers, so I have to indicate their configuration. Carbon 1 is an R, carbon 2 is an S, and then is an R again, and then you put the name. Here it is methoxy, so it's going to be on the second carbon because your longest carbon chain is a 3. 1, 2, and 3. This is my longest carbon chain, so it's a propane. It's on carbon number 2 is going to be a methoxy, so it's going to be 2-methoxy, and then 2-methoxy, and it's a propane, but still I have a methyl in there as a substituent, so it's going to be 2-methoxy, 2-methyl, and propane. If I have something like this, then the first thing that I would need to do is basically choose the longest chain. The longest chain is 2 carbons, so it's going to be ethanol in this case. And on the ethanol carbon 2, I do have the ethoxy. It's going to be 2-ethoxy ethanol. Same thing, choose the longest chain and make sure that carbon number 1 is on the alcohol, or alcohol has the lowest number of carbon. This is going to be 2-methoxy, and it's going to be in an ethanol. If you have a degree of unsaturation in there, please make sure that that your ending, in this case, since you have an ether, your ending is going to be in the alkene, and the OR is going to be a substituent. So it's going to be an ethoxy and an ethene in this case. These are more examples. They are solved problems. You can go ahead and look at those. Now, with respect to ethers, what do I care about is to name the cycle, the epoxide, basically. And ethers, cyclic ethers, are can be named as a common name and IUPAC name. Now, with respect to the IUPAC name, we use the prefix ox, and ox shows that there's an oxygen in the cyclic ring. And then whatever comes after the ox tells me how many basically atoms are there in the ring. In this case, if it's an irane, so oxyrane, irane means it's a 2 carbon or 3 atoms. Okay, let's put it this way, 3 atoms. For the ethane, then it's going to be 4 atoms. And for the olane, then it's going to be basically 5 atoms. And as you go, this is 6 atoms in there. What I care about is how to name epoxides, and there are 3 different ways to name epoxides. You choose the one that you like, but in your homework, I believe that they are using one of them. So this is why, or 2 of them. So this is why I wanted you to know all of them, so that you can draw the structure that you are basically asked to draw in your homework if you are given any of these names. So, so the first way is to name an epoxide as an epoxy alkane. So to name it as an epoxy alkane, you would need to basically choose the longest R chain that includes your cyclic ether, or your epoxide in this case. So my longest R chain that includes my epoxide is basically this over here. This is my longest R chain. It includes the epoxide. So you're going to end in the longest R chain, which is in this case propane. After you end in propane, we're going basically to number the epoxide as carbon number 1 and carbon number 2. So this is going to be 1 and 2. So on carbon 1 and on carbon 2, you do have the epoxy group. So you name it as a derivative of epoxy. And on carbon number 2, you do have a methyl, and then your longest carbon chain, which is propane. Here, my longest carbon chain is a cyclohexane. So on carbon 1 and on carbon number 2, I have my epoxy on the cyclohexane. It's going to be 1,2-epoxy cyclohexane. Same thing over here. See, this is all my R chain, so it's going to end up in pentane. And then you would need to locate where your epoxide is, give it the lowest number on the chain. So that is going to be carbon number 2, carbon number 3. So carbon 2 and 3, we're going to name them as a prefix epoxy. Okay, So that is going to be 2, 3, and it's going to be epoxy. It's going to be pentane. But since I do have stereo center in this case, which is the cis, I have to say that it's cis because here the substituents are on the same side. When you want to name epoxide as oxydanes, normally what you do over here, you number the ring. You number the epoxide ring starting from the oxygen. So you put the O atom at position number 1 and the first substituent as position number 2. So this is going to be number 2 over there, and then you name it. This is going to be 2,2-dimethyl, because remember, we are basically, this is going to be the epoxide. Whenever you name it as an oxidane, the epoxide is going to be your parent name. So your ending is going to be parent name now. So it's going to be 2,2-dimethyl and then oxidane. So I know that it's an epoxide, and on the epoxide, on the second carbon, I have 2 methyl groups. When you name thiols, thiols are the same as ethers. So all what you need to do is drop the word ether at the end and put the thiol. Um, thiols are the same as alcohols. I'm sorry, not ethers, I meant alcohols. So you just drop the OL of the alcohol and you add the prefix or the suffix thiol at the end. It's called the suffix because it's at the end. It's basically the parent name in there. So give it the lowest number. Go ahead and put the thiol at the end since it is the only substituent in there. Same thing over here. This is a cyclohexane thiol, and on the second carbon there is a methyl. When you name amines, they are arranged into primary, secondary, and tertiary. So you have to know what type of amine you are working with. If it's a primary amine, so the ending ends in amine, just name the R carbon that is connected to the nitrogen and put the word amine at the end. So this is going to be methane amine. This is going to be the IUPAC name. It's fine, I don't want you to know the common name. Same thing here is going to be a cyclohexane, and it's an amine. Notice there is no YL in there. The YL is for the common, so we're not using the YL in amine. So you just drop the E of the alkane and you put amine in its place. For secondary and tertiary amines now, they if they do have the identical groups, alkyl groups, then we're going to use the prefixes di, tri, tetra, etc. as in this name. This is going to be diisopropylamine. Now for secondary and tertiary amines. For secondary and tertiary amines, that normally have more than one kind of R group, so you cannot use the prefixes di, tri, tetra, then in this case you have to name the R groups, and you have to basically arrange them in alphabetical order and indicate what type of amine you are working with, primary, secondary, or tertiary, by using the letter N. So you have to indicate where the R group is on N. Let's have an example over here. Okay, if you have this structure and I want to name it, I know that I do have this is a secondary amine. So I know that on this side I have a CH3. So that is going to be an N methyl. Okay, now on the other side you choose the longest carbon chain, and the longest carbon chain, it's an ethyl in this case. This is going to be carbon number 1 of this longest R chain, and it has a methyl on it. So it's going to be 1 methyl, and it's going to be ethane. Drop the E, no E, take it out, and the ending is amine. So see what I did over here for secondary and tertiary amines. If you have a secondary amine, you start by naming the side, the R side that has the least carbons. That belongs to the N, so you have to put the N in there, telling what is on the N. It's a methyl group on the end. This is not a parent name. Now on the other side, it's going to have more carbon, so it's going to be the parent name, so the ending is going to be in A and E. And on carbon number 1, I have a methyl. So see how I started with carbon number 1 here and not there? Because this is the carbon that is connected to the nitrogen. So that is the one that I need to start with when I name. And it's going to be 1 methyl, and it's going to be an ethane, and then stick the word amine in there. Okay. This is how you name this compound. There's another way of how to name this compound. So it's gonna be N-methyl, and it's gonna be 2-propanamine. Let me see how. Okay, let me see. This is gonna be. Uh, you can do 1-methylethaneamine. This is one way of doing it. Another way of doing it is by choosing the whole thing to be the parent chain, and the parent chain is a propane, because it's 1, 2, and 3, and on the second carbon. So now your numbering is from here. You can go, by the way, this way or the other way, and both are right. So you can go this way over here, 1, 2, and 3. On the second carbon, you do have your amine. So on the second carbon, it is connected to the nitrogen. So you can do N-methyl to propane and then amine. This is one way of doing it. Another way, you can do N-methyl. You can go by 1, 2 over there and take this as a substituent. So it's going to be 1, it's going to be a methyl, it's going to be an ethane, and then it's going to be an amine. Now, which one is best? Of course, this one is going to be the best because the parent name does have more carbons in there, but this doesn't mean that this is wrong. Both are going to be right. With respect to the nomenclature of the ketone, if the ketone is a prefix, then we're going to give it the word oxo or the name oxo. If it is part of the parent name, so if you're going to consider it as a parent name, then you're going to drop the E in the alkane and put O and E at the end. You're going to give the carbonyl always the lowest number, the carbonyl of the ketone always the lowest number, and you apply the same rules of naming as alkanes. So let's have an example here. It's going to be 1, 2, 3, 4, and 5. So that is going to be pentan. You drop the E and put on. Never put two vowels next to each other. This is not right. Here I do have a carbonyl and an OH. Look at the priority table at the first slide in this PowerPoint. You're going to see that the ketone is going to be a higher priority than the OH. So the OH now we're going to call it hydroxy. We're going to give the ketone the lowest number, so the OH is going to be carbon number 3. It's going to be 3-hydroxy, 1, 2, 3, and 4. It's going to be butane. Drop the E. It's going to be 2, and it's going to be one. Now, it's really up to you. You can put the 2 between the butane and the one, or you can put the 2 all the way in here. Now, I know that this 2 is going to belong to the carbonyl because I don't have any other functional group here other than the carbonyl. The OH, I already numbered that. This is going to be 1, 2, and 3. See how I started numbering from the carbonyl because it's the highest priority compared to the alkene. So it's going to be 3 and this is going to be 4. So your double bond starts from carbon number 3. So it's going to be 3 cyclohexane or cyclohex 3N and then 1O, whatever you want to do it, it's fine. Now with respect to the aldehyde, with aldehyde again, if it's a prefix or if it's a substituent, we're going to name it as formyl or oxo. And if it's part of the main chain, then we're going to drop the E of the alkane and we're going to get an O or add an OL. Aldehydes are always carbon number 1. The simplest aldehyde is called methanal, okay, or formaldehyde. Formaldehyde is the simplest type of aldehyde, no R's around the carbonyl. Formaldehyde is the common name for it, and methanal is the IUPAC name. So so whenever you look at the name and see an AL at the end, this is the IUPAC name. Whenever you see aldehyde at the end, this is going to be the common name. If you have if you have other substituents in there or other functional groups in there, just arrange them in order of increasing priority. Whoever has the highest priority is the one that ends the name. So here in aldehyde is the highest priority, it ends the name, so I should start numbering from the aldehyde to give it the lowest number. So on carbon number 2 I have a double bond, and on carbon number 4 I do have my OH, my hydroxy in this case. So OH is going to be hydroxy. It's going to be butane, or it's going to be 2-butane, or it's going to be but-2-N and then al at the end. I don't have to say 1-al because always the aldehyde is on carbon number 1. Now if I have an aldehyde and a ketone at the same time, then my aldehyde is always my highest priority. So the ending is Al. Then in this case I need to give my ketone the prefix oxo in this case. So it's going to be oxo for oxopentanal. I would know that my aldehyde is on carbon number 1 definitely. Then my other carbonyl is going to be my ketone. Now a special case when the chain cannot include a carbon of the aldehyde. So if you have a cycle and if you have a carbon coming off the cycle, that carbon, we're going to call it a carb. Okay, so if you have a cycle, the cycle is not benzene. Well, I mean, it can be benzene. Yes, it can be benzene. It's fine. It can be benzene. So if you have a cycle, in that cycle you have a carbon coming out of it, then that carbon is going to be carb, and whatever comes after the carb is an indication of what functional group that carbon is. So if it's an aldehyde, then it's going to be a carb aldehyde. If it's a carboxylic acid, then you say carb oxalic acid. If it's an acid, so this is going to be cyclohexane. It's going to be a carb aldehyde. So for carboxylic acid, this is the highest priority. You drop the E of the alkane and put oic acid. So this is ethanoic acid, methanoic acid. The carboxylic acid, more substituents. This is a phenyl group. All of those are substituents. You just arrange them in alphabetical order. Remember that NH2 is named amino and the benzene is named the phenyl group. The OH gets the highest priority in there, so it's going to be count the longest chain, including the carbon of the carbonyl of the acid. So this is going to be propanoic acid. You drop the E in the propane and put an oic acid. On carbon number 3 I do have a phenyl, and on carbon number 2 I do have an amino. you just arrange them in alphabetical order. To name carboxylic acids whenever you have a special case in there. So as I mentioned, if you have one carbon coming off the cycle, then we're going to name it as a carb. And since I'm comparing now, carboxylic acid is the highest of priority, so my ending is definitely in carboxylic acid. That is going to make my aldehyde and my ketone to be a substituent. So if they are a substituent in there, if they are a suffix in there, which is a substituent, all what I'm gonna do is name. In this case, I cannot name both as oxo because if I do that, then I would know. Then when I'm drawing it, both are gonna be ketones. So I have to differentiate now the carbonyl of the ketone from the carbonyl of the aldehyde. And in order to do this, I'm going to name the carbonyl of the ketone oxo, and the carbonyl of the aldehyde, I'm going to name it formyl. Okay? So on carbon number 2, you arranged in alphabetical order. On 2, formyl. So formyl means it's an aldehyde. And oxo, in this case, means it's a ketone. Notice oxo, where is that? Oxo, we've used it here to indicate basically a ketone, okay? And we used an Al to indicate an aldehyde. So we've used oxo to indicate a ketone, but I cannot use oxo to indicate also an aldehyde, because if I say dioxo, 2 carbonyls, then pretty much I'm going to have a carbonyl over here, and it's going to mistake the aldehyde with 2 carbon double bond O of a ketone. Now for the amide, with respect to the amide, amides are named either as primary, secondary, or tertiary, as we did for the amine. So if you are naming primary amide, all what you need to do is just name the alkane chain. And since amides are they are derivatives of carboxylic acid, then the name the carboxylic acid name, you just drop the oic acid and you add an amide in there. So you name it as a carboxylic acid, then you drop the oic acid, and then you put an amide in there. Why are you doing this? Because amides are derivatives of carboxylic acids. So when you want to name any amide compound, all what you need to do is name it as an acid, drop the oic acid, and then add the word amide in there. Like for example over here, this is called butanoic acid because this is derived from butanoic acid. Instead of the NH2, there's an OH. So if there's an OH, it will be butanoic acid. So drop the oic acid and put an amide, and it will be butanamide. Amide in this case, not an amine, it's a butanamide in this case. Amide is whenever you have a carbonyl connected to the nitrogen, and it's 1, 2, 3, and 4. No need to do any numbers because you don't have any substituents in here. Same thing over there. This is going to be, this is an example that we did. Now this one is basically an amide and not an amine. So it's going to be N. It's going to be it's going to be dimethyl. This is a methyl in here. This is going to be a methyl in there. It is a propane. This is 1, 2, and 3, and it's an amide. So again, it's a secondary amide. So if it's a secondary amide, I have to include where the CH3 is. The CH3 is on the nitrogen, so I have only one N on the nitrogen. So it's going to be N. It's going to be a methyl. But since here I do have another methyl in there, so it's gonna be a dimethyl. It's gonna be a dimethyl, and it's on carbon number 2. See the difference? This is carbon 1, this is carbon number 2, and that is carbon number 3. Your longer chain is this. So it's going to be 2 methyls. So instead of saying N-methyl, 2-methyl, propane amide, then I could have said this, by the way. If you feel that this is confusing, it's fine by me. But since the CH3s are the same, just group them together in a di. Here, it's a tertiary amide. And since it is a tertiary amide, then I would need to indicate these two R groups in there. So see how many N's I have? This is an indication of a tertiary amide. If I use one N, it's an indication of a secondary. And if I use none, where is it? If I use none in here, then this is going to be a primary amide. So I have N-ethyl, N-methyl, just arrange them in alphabetical order. And then on the other end, this is a cycle, and it's a carbonyl in there. So I know this is a cyclobutane, but since it has one carbon coming off the chain, then it's going to be a carb. Okay? We name it as a carboxylic acid. So you are dropping the oic acid, and you're going to put an amide in there. So it's going to be a carbox amide. Here, this one is an N-phenyl. This is a phenyl. The phenyl is on the nitrogen, so it's going to be N-phenyl, and then this is going to be 1 and 2, and there's going to be an ethane, and it's going to be an amide. We will explain what this term is as we proceed. Now, with respect to the esters, you are going to name the alkyl or the aryl group that is bonded to the oxygen first. So whatever group that is bonded to the oxygen first in the ester, you just name it. So here it's an ethyl. What I care about is basically the IUPAC name. This is the common name over here. So this is going to be my R group. You just name it as an alkyl group. It's going to be an ethyl. And then on the other side that has the carbonyl, you start numbering from the carbonyl, and you put ATE at the end. You drop the ic acid because this is again a derivative of carboxylic acid. So you drop the ic acid and you put ATE. This is the same as if, okay, you are naming the acid derivative, and its acid derivative is this. The acid derivative is ethanoic acid. Okay, so what I'm saying here is that to drop the ic acid, leave the O, and then replace it by ATE. Replace it by ATE. So it's going to be ethanoate. So it's going to be ethanoate, ethyl ethanoate in there. This is the IUPAC name for. The common name is ethyl acetate. Now, what is acetate? You're going to see this in your homework. Acetate is this part. I'm going to highlight it. It's a CH3 that is connected to a carbonyl that is connected to the oxygen. This is what an acetate is. And normally we abbreviate the acetate by an AC. So if you have basically an AC, AC is basically an acetate. This is an abbreviation for acetate, and the acetate is a CH3 that is connected to a carbon double bond O. This is called the acetate, the AC. Okay. If you have diester, then we're going to go ahead and number the carbonyl part. You have 3, so that's going to be propane, it's two of them. It's going to be di, and then the both esters, and both esters are going to be um, pretty much a weight. Now, since you are naming esters, you have to start by naming the R group that is connected to the oxygen. So that's going to be diethyl, and then count the carbons, going to be propan. Instead of being propanoic acid, it will be propan dioate. More examples, always start by naming the part that is connected to the oxygen first, and then name the other part of the ester, including the carbonyl. Give it carbon number 1. So that's going to be methyl, it's going to be propan, and then O8. That over here is going to be 2-chloro. This is 1 and this is 2. See how I started numbering from the oxygen? It's going to be 2-chloro. It is so carbon 2-chloro. It's an ethyl in there, and then it's going to be benzoate. Why it's a benz? Why did I say it's a benz over here? I said it's a benz because it's a cycle that is connected to a carbon. So it's definitely a benz. It's not a cyclohexyl, it is a benz, and that is connected basically to the carbonyl. Now it's a benz, it's a set of benzoic acid because this is derived from the benzoic acid in here. So this is going to be the benzoic acid. I am deriving this guy from the benzoic acid, so I'm gonna drop the ic acid and put an ATE at the end, so it's gonna be benzoate. Same thing over here, it's gonna be a tertiary butyl. It's a cyclohexane. We're gonna use the carb in there, so it's going to be cyclohexane. It's gonna be a carb oxalate. With respect to the nitrile, we're going to name it as an alkane nitrile. So if you want to name this, you choose the longest chain, including the carbon. So it's going to be 1, 2, 3, and 4. It's going to be butane and nitrile at the end. You keep the E in the butane, don't take it out because the nitrogen is not a vowel letter. And then of course you put your substituents there. Now I can either name it this way or I can name it as a substituent. Now if it is as a substituent, it should occur at a group that is at a higher priority than it. Like for example, a ketone is a higher priority than the cyanide. So the cyanide is going to be a substituent. In this case, we're going to give it the lowest number after the carbonyl. So the carbonyl is going to be 1. This is going to be carbon number 2. And that can be included in the name. So it's going to be 2-cyano in this case, a substituent. And then a cyclohexanone. Again, if you have a cycle that is connected to a carbon, then that is going to be a carb. It's going to be a carb, and it's going to be a nitrile in this case. So it's going to be a carbo. I'm sorry, it's going to be a carbo. So we said that it's going to be a carbo. So all what you need to do is drop. Here you're going to drop the oxalic acid, and you're going to put the nitrile in there. It's going to be a thio. SH is a thio. This is going to be a benzene. This is going to be a carbo and a nitrile. So instead of saying carboxylic acid, you just drop the ilic acid and the oxalic acid, and you're going to put the nitrile in there. So again, instead of saying, since the nitrile is also a derivative of carboxylic acid, so that is carboxylic acid. So in this case, I'm just going to go ahead and drop the oxalic acid and replace that with the nitrile. Okay, now the term P. What is that? P is P is whenever the substituents on the benzene, they are on position 1 and 4, and we call it para. So whenever substituents on the benzene are on positions 1 and 4, we call this para, P-A-R-A. So this is a para substituted benzene, means that the substituents are on carbons 1 and 4. So here again, carboxylic acid, cyano group. The 2 is going to be on the cyano. This is going to be a cyclopentane, and then it's going to be a carboxylic acid. Whenever you want to name benzenes, benzenes are named either when or substituents on the benzene can be either one substituent, two substituents, or more than base 3 or more substituents. If you have one substituent on the benzene, that is easy to name. Just name the substituent, stick the word benzene to it. Now, some of these are called common names. Other benzenes, whenever you have one substituent on them, we prefer to name them as common names. Like for example, if you have a benzene that is connected to a CH3, instead of naming it as a methylbenzene, you just name it as toluene. This one, instead of naming it as hydroxybenzene, it is phenol. So there are some monosubstituted benzenes that have common names in there. And these are the common names. So this is going to be aniline. Aniline is basically aminobenzene, but we no longer say aminobenzene. So this is why you have to learn these structures together with whatever is in this table over here. Now, as you practice, you will learn it more. Systematic means IUPAC. So benzene carbaldehyde, this is the IUPAC. The common name is benzaldehyde, and this is basically what we use a lot. Same thing for benzoic acid. This is its structure, styrene, acetophenone. So again, the acid is this one in here. This is the AC. This is the acid, and this is a phenyl group there. It's a ketone, so this is why the ending is an O and E. This is going to be phenol. You don't have to know the IUPAC name for. This is going to be methoxybenzene. The common name is anisole, and that common name for the structure is aniline. Now, if you have two substituents on the benzene, the two substituents can assume either an ortho position, a meta position, or a para position. An ortho position is when positions 1 and 2 are occupied. The meta is whenever positions 1 and 4 are occupied, and the para is whenever the meta is whenever positions 1 and 3 are occupied, and then the para is whenever positions 1 and 4 are occupied. And this is basically how you represent the ortho and the meta and the para, this way. Now, if you have substituents on the benzene, and these two substituents on the benzene, they are different, then you're gonna arrange them in alphabetical order. So here I have a bromo, I have a chloro, I have a benzene. These two substituents, they are on positions 1 and 2. So I have to use the ortho, the prefix ortho in there. It's going to be ortho. It's going to be bromo, chloro, because the B comes before the C. That is going to be ortho. It's going to be fluoro. It's going to be nitro, and it's going to be benzene. Now, if you have one of these groups, like one of these over here, if you have a carboxylic acid, if you have a phenol in there, or if you have toluene in there, those are considered to be the root. Okay, those considered to be a common root. With the common root, you go ahead and you name it as a common root, giving whatever substituent on the common root to be a carbon number 1. So here in this case, instead of saying bromo methylbenzene, we no longer say this, because methylbenzene is always toluene. So that is going to be bromo toluene. So bromo toluene. Now, since the bromine is specifically on carbon number 4 of the cycle, then in this case, I need to label those two as a para substituent on the benzene. So a para substituent on the benzene again is whenever positions 1 and 4 are occupied. Whenever positions 1 and 2 are occupied, this is called an ortho. And again, a phenol is a part of a common root. So the part of common roots are basic, you can easily count them. Toluene is one of them, phenol is another one. Okay, so here in this case it's going to be 2-nitro and the phenol, or ortho-nitro, I'm sorry, and the phenol. We don't use numbers. Now if you have a polysubstituted benzene, then what I want you to do is just go ahead and give number to give the lowest possible numbers around the ring, and then alphabetize the substituent names. After you do this, when the substituent is part of a common root, let's have an example in here. So you have a benzene with the nitrogen, NH2, that is part of the common root, which is aniline. So the carbon that is connected to the nitrogen gets number 1, and then you go along the side, either this side or the other side, just to pick to pick the in this case the second substituent that is lowest in number. Make sure that the substituents have the lowest sum of numbers. Okay, please make sure the substituents have the lowest sum of numbers in there. So this is why if I started with the parent with the common root being carbon number 1, I have to go in this direction, giving the second substituent the lowest number, just to ensure that my substituents will have the lowest number. Here my common root is toluene. So if the common roots are known, you can have toluene, you can have phenol, and you can have aniline. All of these are considered to be common roots. So this is a toluene in this case. On carbon number 4, I do have a nitro, and on the second carbon, I do have a chloro in that case. This is an example. Draw the condensed structure for each of the following compounds. 2-bromobenzoic acid. So you start with your benzoic acid over here. This is the benzoic acid. And benzoic acid has a carboxylic acid on it. So on carbon number 2, I do have a bromine. So that is A. For B, I have 3-fluoro-2-cyclohexenone. So we're going to start by drawing the hexenone first. I do have my double bond, my carbonyl over there. And they didn't tell me where the carbonyl is. When it's a cycle, the carbonyl is always on 1. But I know that the double bond is on the second carbon. So that is going to be the second carbon, and this is my double bond. And then on carbons 1, 2, and 3, this is going to be a fluorine. In C, I have a nitrophenol, and phenol is this. This is what my phenol looks like. On carbon number 4, this is 1, then this is carbon 4. 4 is a methoxy, so it's an O and a CH3 in there. Let me see. I'm sorry, I'm doing C. No, I'm doing C. So let me take this one out. This is a 3-chloro-4-nitrophenol. So this is going to be my phenol. Okay. And on carbon number 4, I have a nitro. And on carbon number 3, I do have, this is 1, 2, and the 3, I have a chloro in there. For D, methoxybenzaldehyde. Benzaldehyde looks like this. This is a benzene, and you have an aldehyde in there. Okay, and then on carbon number 3, so this is carbon 1. Carbon number 3, you have a methoxy, so it's going to be an OCH3. For E, 2,2-dimethyl 3-hexanone. So this is going to be my hex 1, 2, 3, 4, 5, and 6. On carbon number 3, I do have my carbonyl of the ketone. This is what it says. And on the carbon number 2, I have 2-methyl groups. So this is what E looks like. F, you have a butanol, so that is 1, 2, 3, 4, and an OH. I'm sorry, no, my OH is on the second carbon, so here you go. So my OH is on the second carbon. This is my second carbon in there, and then on carbon 2 I have a methyl. For G, I have my hexanal, so I have my 1, 2, 3, 4, 5, 6. I added a carbon here. Let's take it out. So 1, 2, 3, 4, 5, 6. So this is going to be my hexanal in there. Now, since it's an aldehyde, I know that the aldehyde is going to be at the end. Okay. And then it's going to be a trihydroxy on the carbon 1, carbon 2, carbon 3, and carbon 4. And all of them, they have OHs in there because it is a trihydroxy. Now for H, 1-bromo-4-chlorocyclopentane. So I'm sorry, cycloheptane. So you have the cycloheptane in here. We have 1, 2, 3, 4, 5, 6, and 7. This is cycloheptane. So on carbon number 1, I have a bromo. Choose any carbon to be carbon number 1, but once you choose carbon 1, just go ahead and count until you reach 4, and then it's a chloro. Now notice here, they didn't tell me the stereochemistry of these two substituents, whether they are cis or trans. So if they told me that they are cis or trans, I have to write them as such. 3-bromocyclopentene. So cyclopentene is this. So this is what cyclopentene is. And on carbon number 3, because the double one's definitely carbons 1 and 2. So on carbon number 3, I do have a bramine in there. And this is going to be I. And the last one, J, is 2-amino 5-chlorocyclohexanol. So you have your cyclohexanol in there. It's a cycle, no double bond, so no circle inside. So this is cyclohexanol. On carbon 5, this is 1, 2, 3, 4, and 5. I do have a chloro. And on carbon number 2, 1, 2, I do have an amino. And amino is in NH2. So this is everything that I wanted you to know regarding the nomenclature of organic compounds for organic 1. I will include in Top Hat a practice sheet for nomenclature of organic compound. It's going to be only one sheet for organic compound nomenclature together with its answers. Please make sure you go after that. This is just an extra problem. It is not going to be an assignment.